It's the kind of power you don't always see, but you can definitely feel it. A truck pulls away effortlessly with tons of weight behind it, an engine barely breaking a sweat as it climbs a steep incline. No screaming RPMs, no dramatic acceleration, just steady, unstoppable force. That feeling isn't accidental, and it isn't just about engine size. It raises a simple but fascinating question. Why do diesel engines deliver more torque? Understanding the answer means looking beyond sound and reputation and into how diesel engines are designed to turn fuel into force so effectively. That's exactly what we're breaking down today, right here, on History of Simple Things. To understand why diesel engines excel at torque, it's important to clearly define what torque is and why it matters. Torque is a measure of rotational force, specifically how much twisting power an engine produces at its crankshaft. When that force is transmitted through the drivetrain to the wheels, it determines how easily a vehicle can start moving, climb hills, or pull heavy loads. Unlike horsepower, which measures how quickly work is done, torque focuses on the raw strength of each rotation. This is why torque is especially important in real-world tasks like towing, hauling, or carrying weight. High torque at low engine speeds allows a vehicle to perform demanding work without needing to rev high or stress the engine. Diesel engines are designed around this principle, prioritizing usable force over high-speed performance, which immediately sets them apart from most gasoline engines. A key reason diesel engines produce more torque is their much higher compression ratios. Diesel engines compress air far more than gasoline engines, often above 20-to-1, raising temperatures high enough for fuel to ignite without a spark. When diesel fuel is injected into the superheated air, combustion creates extremely high pressure inside the cylinder. That pressure pushes down on the piston with greater force, which directly translates into higher torque at the crankshaft. Gasoline engines cannot safely operate at these compression levels due to knock and ignition limits, so their combustion pressures are lower by comparison. Diesel engines, by design, extract more mechanical force from each combustion cycle, especially at low engine speeds where torque matters most. Diesel engines also benefit from how precisely fuel is injected during combustion. Instead of mixing fuel and air before compression, diesel engines inject fuel directly into compressed air near the end of the compression stroke. Modern diesel systems use extremely high injection pressures and finely controlled timing, often delivering fuel in multiple small pulses. This allows combustion pressure to build and remain effective over more of the piston's downward movement. The result is a more sustained force acting on the crankshaft, increasing torque output. Gasoline engines ignite a pre-mixed charge with a spark, which limits how much control engineers have over the combustion process. Diesel injection systems offer greater flexibility, helping maintain strong torque across different speeds and loads. Diesel engines are specifically tuned to produce peak torque at low RPM, which is a major part of their advantage. Because diesel combustion generates strong pressure even at slower engine speeds, diesel engines don't need to rev high to produce usable force. This low RPM torque is ideal for moving heavy vehicles, towing loads, or maintaining steady power on inclines. Gasoline engines typically reach peak torque at higher RPM due to airflow and combustion limitations. Diesel engines, on the other hand, feel strong and stable at lower speeds, allowing them to deliver consistent pulling power while reducing mechanical stress and improving efficiency under load. The physical design of diesel engines further supports higher torque output. Many diesel engines use a longer stroke relative to their bore, meaning the piston travels a greater distance during each cycle. A longer stroke increases the leverage applied to the crankshaft when combustion force pushes the piston downward. Since torque depends on both force and leverage, this geometry naturally favors torque production. Gasoline engines often use shorter strokes to enable higher RPM and greater horsepower potential. Diesel engines prioritize durability and low-speed strength, and their longer stroke design helps convert combustion pressure into usable rotational force more effectively. Turbocharging plays a major role in enhancing diesel engine torque. Turbochargers use exhaust energy to force more air into the cylinders, allowing more fuel to burn efficiently and increasing combustion pressure. Diesel engines benefit especially from this because they lack a traditional throttle plate, which reduces pumping losses and improves airflow efficiency. The result is stronger torque, particularly in the low to mid RPM range. Intercoolers further improve this process by cooling compressed air, increasing density and combustion efficiency. While gasoline engines also use turbocharging, the combination of diesel combustion characteristics and forced induction produces more consistent and usable torque gains. Diesel engines deliver more torque because they are engineered around producing force efficiently and consistently. High compression ratios create intense combustion pressure. Direct fuel injection allows precise control over that pressure. Long-stroke designs improve mechanical leverage, and turbocharging ensures a steady supply of dense air. Together, these factors allow diesel engines to generate strong torque at low engine speeds, exactly where it's most useful for real-world work. This is why diesel engines dominate in trucks, heavy equipment, and long-haul vehicles, where reliability and pulling power matter more than high-speed performance. Their torque advantage isn't incidental, it's the result of purposeful design. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.